let's talk about the technology. This quote is from one of the inventors of the web browser. Software is eating the world. We've seen this from our own consumer lives. You need a computer science degree in order to fix a car these days. And everything we use is getting more and more kind of intelligent, and software is coming into it more and more. And why that is really Moore's law. Gordon Moore was one of the founders of Intel, and they discovered very quickly that about every 18 months, they can double the amount of transistors that they can put on a computer chip, while the cost goes down between 30 and 50%. That means that every system actually gets twice as powerful and cheaper every 18 months. And we've seen this in everything that we're using in our consumer lives. To be on this trajectory is unbelievably powerful. If you could be on this trajectory with your own product development, with your own continuous improvement, that's incredible. You'll win very, very quickly. The problem is that from a technology standpoint, it's extremely expensive to stay on this trajectory. Google, who is our partner for data centers, they spent $30 billion in the past 3 years to be on this trajectory, to continuously up the game in the systems that they have, in the data centers that they have, so they can deliver that power to Google, but also to their partners. Now, this creates a huge mind shift in how you actually take build or buy decisions. If you take a build decision, that you want to build the capabilities in-house, and you want to actually invest in a data engineering organization, data analysis organization, and put everything in your own servers, you're going to take a spot on this curve, and you're going to stay on it. But actually leveraging the cloud, something that is becoming more and more commoditized every single day and more powerful, if you actually work on a software as a service basis with the people who are making this investment, then you can stay on the curve for actually less money than you would actually pay if you did it yourself. And obviously the follow-up question to that is usually, what about the cloud? Is it secure? And I bet if you ask anyone, would you like to be on the cloud? There's no reason to say yes to that blanket question. But if you ask them, would you like to be on the cloud if you had 99.99% uptime, if you had better security than you can yourself at lower cost, then the decision is all of a sudden easy. Because the question about the cloud, CIA is on the cloud. The most important thing that you currently have in your organization, well, maybe not the most important, but a very precious asset, your bank account, you're not hosting that in your own data centers, your bank is. And there's nothing different about hosting the process data in the cloud as long as it's done right from a security perspective. So let's talk about people. So ever since the early days of computer science, people have talked about machines taking over and replacing people. There was a very smart computer science professor called Licklider in the 50s who came up with the idea of human and machine symbiosis. Now, a very important thing in thinking about this Industry 4.0 journey is where to start. Cisco actually did an evaluation of their industrial IoT projects, and they saw that 25% made it out of pilot. It means that 3 out of 4 just fail. And the reason why they fail is because they didn't have a clear problem to solve. They didn't know where the ROI was going to come from. They didn't know who was going to use it. They only tried to fit technology for the sake of technology. And that's completely the wrong way to do it. So if you're looking at adopting technologies like this, you have to start with what's the Pathfinder mission? Where is the ROI going to come from? Because that's going to dictate everything. Then you can easily actually sell the project internally because you know where the ROI is going to come from, but also you know who's going to use it, what data they need to collect, and how it's actually going to be digested. And you can then create a very structured ROI plan over 90 days or 120 days, and you can hold people accountable to actually achieving those goals. From a hardware standpoint, a lot of wire and cable customers ask us about how we can actually tie into all the different sources and old equipment. And the reality is that most machines, actually since the 70s and 80s, have some form of communication port that we can tie into. And so with that flexible device, we can actually deploy very quickly and to a lot of wide variety of data sources. And really what it comes down to is how can your organization, through the different levels, start collaborating and communicating with data to take better decisions and actions faster. One thing that we often see as a shift is actually how everyone can sit on the same side of the table and discuss the data instead of arguing over hypotheses and incomplete data. Because what you're doing today in terms of pen and paper data collection or operators writing down how much downtime they had and for what reason, that can easily be biased. And as soon as there is a possibility of bias, then there's an opportunity for people to question it. But if you can automate it, and then there's no question, and people can sit on the same side of the table and make this flywheel of optimization turn much, much faster. I wanted to give an opportunity to ask questions. Does anyone have questions so far? Yep.
How compatible are these kind of systems with existing software packages, either on the maintenance side, like Maximo, or like a database like Microsoft Access?
Yep. So integrations is like a relationship. It takes two parties. And so this is extremely compatible because you can do REST APIs that are documented and open, so you can tie into other systems. But it really requires the other system to have some form of communication capabilities. So an Access database, absolutely. ERP system, it depends on who built it and how cumbersome it is going to be to make that handshaking communication between the systems. But from our side, it is open. We don't believe in closed systems because there's so much context needed from other systems to make the analysis as valuable as possible.
Is any of your products actually in a two-way, so they're uptaking all this information, using an algorithm to make a specific decision, and then commanding the machine to do something different?
Great question. Not yet. So, and there's an interesting challenge there because the cloud is fantastic for the scale of analysis, especially between multiple plants, and you can do a lot of computations very quickly and powerfully in a cost-efficient way. But if you want to actually control the machines, there is a connectivity dependence between the cloud, because your ISP might go down, you might have troubles with access points, or just latency. And you don't want to have that if you're going to control the machines. So we're actually launching by the end of the year a new edge type of control. So you can have the logic of the control on the edge, on all devices on a line at the same time, and actually execute commands on the edge without dependency of the cloud. But, like I said, it's in development, so it'll be by end of the year. The last thing to think about is, there's a lot of data, and everyone is becoming more and more data-driven and data-centric. Previously, it's been very expensive to do it. And you'd have to purge data from machines after 7 days, or you have to purge data from a local system after a couple of months. And so data's actually been a depreciating asset, because the more you had, the slower your systems were, and the more expensive it was to scale it. But working with our partner Google and other cloud partners, the marginal cost of data is so low that it's virtually zero. And then when the marginal cost of keeping more and storing more data, then data becomes an appreciating asset because your systems don't get slower, and actually you can use it in the future for algorithmic predictions of quality and of machine failure. So thinking of data as an appreciating asset instead of a depreciating asset is kind of a key mind shift here.
Now let's review some key points from the video.